This one?
Yeah, this one is fine.
Okay.
Thank you. Yeah.
Hi there, everyone. Hi. Welcome to International Astronomy Day and SFU Science Rendezvous. My name is Susanna. I'm president of Vancouver Center of the Royal Astronomical Society of Canada. If you're not familiar with us, I just wanted to let you know it is we are one of the oldest societies in Canada, founded in 1868. And Vancouver Center was founded in 1931. So we've actually been around for quite a long time. Today has been an amazing day. I'm sure you've been enjoying all Astronomy Day and SFU Saturdays as always, alongside faculty and students of SFU as well as members of the RASC. I just want to let you know a little about the history of International Astronomy Day. It started in 1973 by Mr. Burger, who was president of the Astronomical Association of Vancouver Center. His intention was to set up telescopes at museums and centers to help passers-by. Today, since 1907, all three of these events on the International side. It's always scheduled for Saturday from mid-April to mid-May, whichever Saturday is closest to the first quarter. You know about the disaster on telescopes observing. So this means that every year International Astronomy Day falls on a different day. For 2016, International Astronomy Day actually is next week on Saturday, May 14th. But we here at the RASC wanted to celebrate it today so that we could host it in conjunction with SFU's Science Rendezvous, because Science Rendezvous is always on Saturday before Mother's Day. In addition to all of the activities and displays that you've been enjoying, RASC is thrilled to have such a high-profile speaker coming to you today. We actually invited Ray Villard in August of 2015. We wanted him to come for January. But because of work commitments, he wasn't able to. He said he had to delay his visit to the spring. So with his agreement, we were able to coordinate his visit to Vancouver with our International Astronomy Day celebrations. So at this time, I just want to take a moment to thank all of our RASC volunteers who have all given of their personal time so that you can have fun today. I also want to thank the faculty of science here at SFU for contributing to Mr. Villard's lecture, both the financial contribution as well as giving us this lovely lecture hall was able to. Before I pass on the next one, I just want to make sure everyone knows about our free raffle today. With the donation from Skywatcher Telescopes, we are raffling this Burnaby telescope. Tickets for the free raffle can be filled out at our membership table when you leave the lecture this afternoon. Go to the left, go that way, and our membership table is there, and they have some raffle tickets for you to fill out, and the draw will be at 3 o'clock. I also wanted to mention, some of you might see that we have a video camera down here at front. We are live streaming this video on the internet. The Vancouver Center a couple of years ago partnered with Astronomy Without Borders, which partners astronomy clubs from 2 different international locations so that they can enjoy astronomy together. So RASC Vancouver is partnered with the Astronomical Association of Jamaica. So the Astronomy Club of Jamaica is also watching this lecture live right now. So hi to Jamaica, everyone. Hi. Perfect. So now I'm going to hand the microphone over to Mr. Barry Shanku, who is our director of our speaker program and also a good friend of Ray Villard.
Thanks, Susanna. To all the young people out there, I'd like to say you're living in a very, very special time. When I was your age, I did not know a world that did not have TV, that did not have telephones, that did not have airplanes. For me, they were always there. For you, you're living in a special, never known. So without any further ado on my part, it's my pleasure to introduce our talk this afternoon, just entitled Cool Pictures from Hubble. And it's my pleasure to introduce from the Space Telescope Science Institute in Baltimore, Maryland, Mr. Ray Villard. Ray?
Thanks, Jerry and I go way back to the early days of Hubble. I've had the chance to come up here a number of times and talk to the RASC. And we just keep getting more and more pictures. Now, I brought a lot of pictures from Hubble, but I know especially students are interested in planets. I brought a lot of planet pictures too, and to get you all squared away about Pluto and all that stuff. So I've got a nice collection. I'm going to go through it quickly and then maybe more time for questions and answers afterwards. How many folks here want to be an astronaut someday? A few? Well, by the time you're grown up, NASA hopes they'll be sending people to Mars. Who wants to live on Mars? Mars has a nice restaurant. Great food, but no atmosphere. So how many, now up here in Canada though, you get to see the sky more than we do down in the States. How many people have seen a view like this? Few people? Anybody out counting all the stars? So this photo was taken by my dear friend John Deming, who's a member of the RAC, from Hornby Island, not that far from here. So we look at the sky. The sky looks fairly static, a lot of pretty stars. In this picture, there's the planet Mars. So if you see a very bright star, that might be a planet. And the wonderful view of Jupiter, Venus, Venus and Jupiter, and the Moon. Well, that looks like they're taken from Hornby Island. So I'm sure you've seen these things in the sky and wondered what the first star which you might see, which is usually the planet Venus. It's not a star at all. And even went over big cities like, I don't know what city that is, far over big cities, you can see the moon, of course, illuminated in part, depending on the phase, illuminated by Earthshine, or a full moon. It's a wonderful photo, though. I like this. The dark side, shadow side. We're seeing illuminated by light coming off of the Earth. And as you know, you can follow the moon going through its phases as it orbits the Earth and the sun lights it up. Early peoples had very strange ideas. We call that cosmology, about how the universe is put together. This was from the Egyptians. This was the land, the sky goddess, and the sun and moon sailed back and forth through a small boat, rising and setting. The Greeks thought we were the center of the universe. And one thing for you to ponder, there is no center to the universe, there is no edge to the universe. I'm going to show some pictures which might help there. I found this online. I thought this was really pretty cool. This is artwork. It's not a picture. But here on Earth, this is how we kind of see the universe. We think we're the center. We're the planets that orbit the sun. Far out beyond are the stars around us. Those stars are just one local neighborhood in our Milky Way galaxy. And I'll show you there's lots and lots of galaxies. And they're probably all you look to be beginning of tiny cell. I found this on that. I think we understand. Rough dark, it's a clutter picture. With how here on Earth, this is how we kind of, the universe is full of stars. And in fact, we call this the universe of stars. Those stars are just making stars very fast. This is a picture of the tiny piece of the sky where a bunch of stars are clustered together. If we look beyond, the universe as a whole are seas of stars. Little shape here, and every little shape and every dot is the universe is millions of stars. In fact, one impression teacher, there's many stars in our Milky Way because there are grains of sand on the beaches of the world. Actually, I did that calculation. I think I factor it. And there's as many galaxies in the universe as there are grains of sand. 100 billion galaxies make a universe. 100 billion stars make a galaxy. People have been looking at the sky. This is from the tapestry from the year 1066, and that Latin says, "Holy cow, look at that thing up in the sky." It's an engraving of a comet, Halley's comet, in fact. And now we can actually photograph these things. This is a wonderful Hubble picture of a comet coming by. In the background are a few stars, and farther back still is a sea full of galaxies. Native Americans chronicled the explosion of the star, a supernova. And then with big telescopes like Hubble, you can see this, they kind of call it stellar roadkill. All of it star guts. But that will be used for future generations of planets and stars. An early telescopic sketch of the planet Saturn. And now with Hubble, we have followed Saturn for the past 25 years. And as its perspective changes, we can see the magnificent ring system around this planet that is a billion miles away. I want to start, because you all see it in the sky, and this isn't Hubble, but it's still fun, is thinking about the moon. Here's a picture of the moon passing in front of the Earth. And one thing I want you to remember, we're looking at the back side of the moon. That's the side you never see from the Earth. The moon always keeps one face above the Earth. You can see the moon is smaller than Earth. They've been companions for the past 4.5 billion years. This side of the moon you know, and it's pockmarked with giant impacts. And people have had fun over the years. They trace it out. This is the rabbit of the moon. You can imagine that. This is a woman in the moon. Oh well, that's the best they can do. But I want to draw your attention. First, the moon is pockmarked with craters. It really got beat up about 4 billion years ago by all the asteroids and meteors out in space. One of these down here happened only 100 million years ago. What was happening on Earth 100 million years ago? Anybody know? The dinosaurs. The dinosaurs saw. Well, there's the crater, Tycho. The dinosaurs saw that impact. That would have been really cool. But if they had intelligence like us, they would have said, "Holy cow." That happened here, and it did. 40 million years later, a comet or asteroid hit the Earth. This was a bad day for the dinosaurs. It was a good day for mammals. Otherwise, the velociraptor would be standing here today. So people thought about going to the moon. This is a movie made, fanciful movie made 100 years ago. And notice the bullet-shaped spaceship. Well, when we did go to the moon back in the late 60s, early 70s. Here's the bullet-shaped Apollo. A picture of Earth in the background. And of course, the moon is a magnificent desolation, 4.5 billion years old. Moon rocks are really cool. They're some of the oldest things you can find. Yeah. Good question.
I heard that the moon smells like gunpowder.
Does it smell like gunpowder? I've never smelled it. It might. So it's a bunch of crushed rocks, the surface, so I'm not sure if you have it. Let me show you the Hubble. What we've done with Hubble. I have to bring this up because this is the first question I get from kids all the time. What about Pluto? So this is a picture we took 25 years ago. You can see Pluto and its giant moon, Charon. And then we improved Hubble. We could actually photograph the surface of Pluto. We weren't sure what light areas and dark areas were, but we thought they were interesting. And then we took one picture that was used by the astronomers who sent a space probe to Pluto last year. You all saw that from Pluto. The pictures, I'm going to share a few with you. But they wanted to look with our Hubble. They said, we want to look at that bright thing next to the dark thing. It's got to be interesting, right? So here's the picture from the New Horizons space probe. You can see the bright thing. That's a big frozen plain. Mountains, craters, a very complicated world. I don't know if anybody's living there, but they would have gotten upset at a spy satellite going by there. But magnificent, now this isn't Hubble, of course, this is from the New Horizons. But again, these icy plains, this is, we think, is an ice volcano that erupts liquid water rather than molten rock. A frozen lake response on Pluto. Pluto, of course, is very cold, but it's had a complicated history. These funny plains next to giant mountains. And I looked at this. This made me think of up here in British Columbia. Look at those mountains. They're much higher than the mountains you find here. So Pluto is a very complicated place. This is the moon that orbits Pluto, Charon. And some material coming off of Pluto turned the cold brown for whatever reason. Anyway. So wearing a hat, it looks like New Horizons. So our sign of success, there are 9 planets. I don't care what your other teachers say, if they do. Pluto is a planet. It's got all the characteristics Earth does, except it's cold and everything's frozen. But it's kind of silly not to call it a planet. Now, we call it a dwarf planet because compared to Earth, Pluto and its moon are pretty tiny. You see that you could almost fit it up in Canada. Okay? So, all right, look, we got a little planet and we got Earth. But you know something? If anybody lived on Jupiter, they would call Earth the dwarf planet. At that time, Earth could be a moon of Jupiter. Looks like the red spot's looking at it. That's Jupiter. Okay, the red spot is shrinking. It's a giant hurricane. Earth would fit inside the red spot, although it's getting smaller. And we saw other red spots. We called this red spot Junior and baby red spot. And just like the old game Pac-Man, the big red spot ate the little red spot. This guy, he sneaks by the big red spot every couple of years. He hasn't been eaten. Wow, look at that. What's going on? Somebody got some dirt on his lens. What in the world could that be? They can know?
Yeah, eclipse.
Kind of yes, it is an eclipse. They're very good. If you were on Jupiter, that's a shadow from one of the moons, the moon Ganymede. And to prove it to you, I've got a better picture. But we liked it because it looked like an evil eye looking back at us. It's how when you look at something, it looks like it's looking back at you. But so you can see moons here. I've named them. The moon of, they're all over the place. Shadow of Europa. Callisto is casting a shadow here. Io is casting a shadow there. And that's something amateur astronomers can follow through their telescopes. These are big moons, about the size of our moon. Let me talk about, I'm going to go into deep space, but everybody, I said how many people want to live on Mars. Mars is a small planet, and yes, it doesn't have much of an atmosphere, but NASA will like to send people there. That's Mars through a telescope. And they got people interested centuries ago because it looks like it's got polar caps, and maybe polar caps could mean ice and water and good stuff for life. Early astronomers thought they saw canals on Mars, and people toyed with the idea that maybe there were Martians who built canals to bring the water from the polar caps down to the equator. That even inspired the classic H.G. Wells story, War of the Worlds, where the Martians come to Earth and try to take over the Earth. And the Army can't stop them, but they die because of microbes. They all catch cold. Gone. Now Hubble pictures of Mars show there's no Martians, there's no canals, there's no cities. It's a cold, very arid planet. But it does have a fascinating history. It's got a great rift valley, much bigger than the Grand Canyon down in the United States. It's got immense volcanoes. This volcano is 4 times higher than the largest mountain in Canada. Immense features. So Mars has had an interesting history. Here it is. Just a humongous thing. Do you think it had an ocean about 4 billion years ago? So you think there might still be life there? But it would be microscopic life. It would not be things with 3 legs or something. But we do plan, NASA is very anxious to humans to Mars. Very cold and dangerous place to go, but really good assembly. And in the far future, maybe you can warm up Mars and make it more like Earth. So this is a good time to buy land on Mars. This is cheap. You should get an ocean there. So Earth, now my question to you, I said there's 100 billion galaxies, 100 billion stars. Within our galaxy, there are probably 1 trillion planets. Could there be other planets like Earth? Planets with water and an atmosphere. Well, we have found a bunch. This is just artwork. They're bigger than Earth, so we call them super Earths, because that's where Superman comes from. But we don't know what the conditions are like. We're looking for planets in the Goldilocks zone. Not too hot, not too cold. Ours is kind of chilly. Venus is as hot as your oven on South Clinton. But Earth is just right. We have a bunch of Goldilocks planets, or something that we live in. And we have oceans. And there's one we found just 40 light years away, which is a big distance, but still decent. So, what I would like to know, although this is centuries, thousands of years in the future, if we could travel to these planets and see what alien life looks like, where Darwinian evolution is taking place in another world. I would love to see that. We will identify worlds like that in your lifetime, but you'd have to travel there. Not that I want to meet these things face to face, but you'd have to travel there. All right, let me jump ahead to Hubble. Let's look at. Now, the universe we see with Hubble and other big telescopes is more than just stars. It's a what's the word I want? It's a crazy universe. If you can imagine it, and it's allowable within, it's a compulsive universe. If you can imagine it, and it's allowable within the laws of physics and chemistry, it's happening somewhere. I showed you the myriad stars that we have. This is the very center of our galaxy. The black hole lives right there. And it has stars for lunch every now and then. You can't see the black hole. It's got a lot of stars around it. It weighs as much as 3 million suns. These are where stars are born. These immense clouds of hydrogen, and the stars collapse. But this is a stellar maternity ward. And our sun may have been born in something like that 4.5 billion years ago.
We're just getting feedback from Jamaica. They're having a problem hearing. Yeah, it's a little higher for you.
I'll try to talk a bit louder.
How's that?
Let's try. Okay, Jamaica, can you hear me? Canada to Jamaica. Is that what?
I'll try that. Thank you.
Thank you.
This we just photographed. This is a Hubble bubble. 7 light years across, which is, I don't know, like 30 trillion miles or something. So this star is blowing off a lot of material, and it's blowing a bubble into space. Now, we've known about this for a while. This is the best picture we've seen with the Hubble. Here, I want to talk a little bit. You know, the stars are being born. You see these little things here? They look like stalagmites in a cave, and we call them elephant trunks. Within these big towers that form, new stars are being born. And this was the classic, I'm sure you've all seen this. Anybody hasn't seen this one? These are the Pillars of Creation. I cooked up the name just for fun. It's my video producer. But these are towers where new stars are being born. And it got everybody excited because it looks like it's living, doesn't it? It looks organic. And but these are all over the galaxy. This one is different. This is classic to astronomers. This is the Horsehead Nebula. As we see in infrared light, we can see more of it. But when I was a kid, things like that really inspired me. Hubble, of course, provided a better picture than we'd seen before. Here's a dying star. What nickname do you think we gave that object? What would you call it? Yeah.
Maybe like a ball.
I can't hear you.
Looks like a ball.
A ball.
Okay. Bow tie. Yes, bow tie. Called the bow tie nebula. There's a lot of things out there that look like that, the way the star shoots up material. We call it the butterfly. Does that work? What would you call that one? Bloodshot eye. Somebody call it the eye of God. I don't think God's got eyes. That's another star. Our sun will do this in about 5 billion years. It will blow up its outer layers. Some of you worried you thought I said 5 million years. It's 5 billion. And I love this because it's spooky. This is another one of these elephant trunks. This is the Cone Nebula, but our nickname for that is Cookie Monster. Oh, this we had fun with. Another star shooting out material. What do you think we call that? Yeah.
Looks like an angel. I don't know why. It looks like the head on top and then the wings like behind them.
Very good. It's this we call it the snow angel. So you nailed it. But again, this is all very violent stuff going on out there. But the universe is an endless cycle of birth and death and rebirth among the stars. I don't have a name for that. Anybody want to give that a name? It just looks cool. It's a piece of the star that exploded, and all the gas is tangled up like a ball of yarn, and it's glowing. And all those, it's a lot of different elements. Those will eventually form new stars and planets. It's a big feature. But amateur astronomers know. We just photographed a little piece of it called the Villard did. This we had fun with. This is what happens. And the sun probably did this billions of years ago. When a young star collapses under gravity, for a little bit of time, it will make planets will be born in the disk. Here's the star. Planets will be born in the disk, but it will shoot out a jet of material. So we had fun with this. So what do you think we did with this? What does it look like? It looks like something from science fiction. So what do you think we did with this one? What name do you think we gave it? Ring of Power? I didn't bring the picture. I do have one called the Eye of Sora. That's another story. So we said this was the cosmic lightsaber. It's like something Darth Vader would do. So we had fun with that. So let's go beyond the local stars to the Milky Way. And on a nice clear night, maybe up in Burnaby Island, you can see this. Has anybody ever seen the Milky Way from up here in Canada? Magnificent ribbon of light. It was in John Nemi's picture when I began. This is our galaxy. The galaxy is built like a pizza or a dinner plate. It's a big flattened disk of 100 billion stars. So if you look along the edge of the pizza, it will look like that. If I got a pizza like that, I might send it back. I don't know if that makes sense. If you look along the edge of the pizza. So to get that idea across, that's not the Milky Way, that's another galaxy. Right? So anybody living there sees the same stuff we do. It's the edge of the galaxy. What is that? Well, that's lots of dust to make newborn stars, lots of star clusters, and so on. This is another one, very pretty little picture of a galaxy with the dusty edge. Another one too, they begin to look like little flying saucers. A lot of galaxies, billions and billions and billions, are made like this. Now this is, you should know where you live, okay? So this is a piece of artwork. This is where you live. This is an artwork of the Milky Way. There's the center where the black hole lives. That black hole is 27,000 light years away. Now for you math geniuses, the light year is 6 trillion miles. So, or I'm sorry, it's a long distance. So anyway, it's a black hole. There's a bar, not a big bar. This bar closes at 2 a.m. It's a big bar. And these magnificent spiral arms, and we are right here. So we don't live any place special. We're just out in the suburbs of the galaxy. And here's a picture of a real galaxy that looks just like ours. It's got spiral arms and a bright central bulge. And looking flat down on top of the pizza, this is what you see, this magnificent spiral pattern. Some do have huge bars, and they're quite dramatic. We photograph those in public. The blue is young stars, and the milky stuff is older stars like the sun. What do you think we call this? This is been in astronomy for a while. What would you call this? Yeah.
Like a planet?
And it's a whole galaxy. It's a big galaxy. Yeah.
The Death Star exploding?
Death Star exploding. That's good. I like that. For whatever reason, when they blow it up, they have a ring come out of it. No, it's not exploded. You all saw the latest Star Wars? Why did they build another Death Star? They blew up the first one, they blew up the second one. You think they'd catch up? No. This is a big halo. These little white dots are globular clusters, and again, a lane of dust. This one I like. These are two. This galaxy is going to be lunch. This is a giant elliptical galaxy, and it's going to eat the spiral galaxy. And that's what ellipticals do. So galaxies eat each other, and they get even bigger. Called galaxy cubes. Here's two galaxies colliding. They run into each other. That's going to happen here in about 6 billion years. We lane of dust. A neighboring galaxy. This one I like. These are two. So when you go out in the sky, would be Polish stars. This is a giant elliptical galaxy. But you don't have to worry about it. It's a spiral galaxy. That's what we look. And then galaxies collectively, galaxies eat each other. Giant clusters of galaxies. And we see some very strange things here. Which really take a long time to explain, but they run into each other. Space itself, that's going to happen because of gravity, because that's why you look at some of these things, neighboring galaxies. This one I like. These are two images. And you galaxies even like Polish stars. So the universe is cluttered with stuff. You don't have to worry about stuff. And you get these kind of pictures. So we look, and the galaxies, the galaxies. So this is the deepest, largest view, and we see some very strange things here. There are 10,000 galaxies run into each other. Space itself, very tiny piece of sky, because of gravity, as small as looking at something that is so strong. And we're looking at the galaxies, we look deep into space. And the deeper into space we look, the farther the universe is cluttered with stuff. So this is the way our history goes here, very long, and you get these kind of picture particles in the galaxies. Yes. So this is the slice of the universe. Of course, there are 10,000 galaxies. Space itself, very tiny. And the idea today is this is a long chain of science reasoning for this. And we're looking at our galaxies expanding galaxies. He calls it space with the universe is cluttered. Space, you know, just get this big picture particles in a parallel universe. In fact, there's one funny piece of data. Someone suggested it's so the reality is very overwhelming. And our idea today is Earth is a long chain of science, and our whole universe is looking at our universe. So these are the wonders of the world called telescopes today. So with that, let me open it up. I'm sure this will be a question. Yes.
Are there any observable examples of time dilation in space?
Yes, that's a very good question. So time dilation is the stretching of time to the intense gravitational field, but also the expansion of the universe. Like we see, there's the galaxies just turn red. So with that reddening is effective time dilation, stretching. If you're in a spaceship traveling at a very high rate of velocity, time would go by slower than usual. So time dilation, and in fact, the satellites used for GPS systems to be able to take that radiation. There also the expansion of the universe, and that changes the rate. What's outside the universe? Another universe stretching out. Well, there could be, not from a spaceship travel, there could be other. Why should there only be one Big Bang? I think this gave us and satellites choose what happened before the Big Bang. We have to take that reduction into something. So it could be an infinity of Big Bangs. The universe is expanding and collapsing. Some have life, some don't have life. We live in the Goldilocks. None of everything is just right. Stars, there could be. Of course, if they're expanding faster, why should there only be one Big Bang? It's expanding slower than collapsing. So our universe, what happened before the Big Bang? are the open timelines. We look at them, not so much the issues, just how we understand the direction. But there's been, I wish I could figure out other universities, so our university, Stephen Hawking talks about a dictionary time. I don't know about that dictionary. Some have water. Are the open not so much you understand the direction. Yes, I didn't get into that here. The universe in fact is accelerating. It's expanding faster every day. You don't understand that. And they do that forever. Which means the universe will be very dark and lonely in the far future. Observations of the Hubble suggest whatever this dark energy is causing some have water. And we stay at least for 30 years. So your property levels after 20 years of this, I didn't get into that here. The universe in fact is just how much it makes itself. It's expanding faster every day. You don't understand it. And they do that forever. Yeah, I didn't get into that, but we keep fixing it up. It's got better cameras and better computers. The astronauts did that, but that part of the NASA effort is over. NASA's big effort is to send people to Mars. So they don't fix up Hubble anymore. I didn't show a picture, but we're going to launch a bigger telescope than Hubble in a couple of years. And that can see, so far, you'll see just what the universe was like not too long after the Big Bang itself. So it's like trying to get baby pictures of the early universe when the galaxies first formed. Yeah.
Where are the bubbles on this picture?
What are the what?
What are the bubbles on this picture?
Oh, the bubbles. Those bubbles represent other universes. Now, our universe isn't bubble shaped, but it's the best we could imagine. I can't hear you. You gotta be louder.
Is it true that Hubble telescope might fall back to Earth?
Oh, can Hubble fall back to Earth? Well, I hope so. Because then I'd be out waiting for pieces and I could sell them on eBay. And maybe film. It's not going to fall back anytime soon. Now, the mirror is 2.6 meters across. That would not burn up. That would land somewhere. NASA will probably, after 2030, have it crash in the ocean. You can't bring it back in one piece, it's too big. So they'll get rid of it before it bothers anybody. But I do wish it would just fall, because I would like a piece of it. Yeah.
The previous picture showed that artist we can see in the galaxy. Why is there like that giant galaxy like flashing?
Sorry, why is there
The
like
galaxy is firing all the way over. It moved like
Now-
left and right, like there's like this stuff.
that one? Okay, that's a star No, stars will have these, due to the physics of light coming through the telescope, they will have these features, diffraction spikes. So anything that is a point source of light, because it's a star, anything that doesn't have diffraction spikes is an extended object. So there's only one, I can only count one star in this picture. Every blob is a galaxy. And small blobs of far galaxies, the big blobs.
The same called black holes.
Oh, yeah, we got two of them. See, those stars, we're looking deep into the universe, but these stars are within a galaxy. So it's like looking through a dusty window at a distant mountain. These are nearby, without the window. But these things are billions and billions of light years away. Yeah.
From the Big Bang to like that moment, how is it?
Yeah, that's a good question. I should have said that. We're looking back over 13 billion years. So the light from the time this galaxy you see has been traveling for 13 billion years and finally reached us. So it's like postcards. It take a long time to get here. But the light travels, and so the Hubble, all telescopes are time machines. And the farther you look, the farther back in time you go. How old are they? 11. So there are aliens on a planet 11 light years away, and they have a big enough telescope, they could see you when you were born. It's the only information, I don't think I've ever been. It's the only information they have about you, right? In another 11 years, they would see you as you were today. But they have to wait 11 years. In this case, we have to wait billions of years before the light comes to us. So this is a big history book. We're flipping back through the pages of the history book to see how the universe built stars and planets and galaxies from the Big Bang.
How long is this like after the Big Bang?
Oh, so the things, well, the oldest slide here would be a little over 50 billion years. So, yeah. So, Google Hubble Space Telescope, Google Space Telescope.org. And you see a lot of pictures. You come on the computer, you make great screensavers. Thank you.
Thank you, Ray. So don't forget about the free draw for the telescope. I'll put it to the left at our membership table. Have a great time for your rest of your afternoon.
Susanna, you can do a message from Jamaica. Jamaica want us to read this message from them.
Oh, I'm sorry. You know what, tell them that we will read it at the evening lecture. Okay, because unfortunately we're already going.